differential theory. Usually it's good for calculate the loop, calculate of loops like this. And square root of 2 is roughly equal to 1.4, is 7 divided by 5, and you can use this way to get the approximation. So approximation, these are some other example, and first approximation and error second, and you can see how good the approximation is. So some other application of the Taylor theorem, the curvature usually can represent this in this equation, and you can see basically these are y equal 1 can be in this point p can be approximated by y equal x squared divided by 2. Another example is the arc of the angle alpha. So it's basically S is actually equal to R radius divided the angle. However, it can be approximated by S equal roots. And if you use some angle calculation, you actually can see A equal to this, B equal to this, and plug it in, it will be something like this. And you can get the approximation like this. And some other application is the bending of a beam. The curvature is also can be represented by this equation, and if you expand it in tangent alpha, because alpha is small, and you can get the differential equation of bending of the beam. I will show you some bending of the beam, some information. So Taylor series can also expand in several variable, and these are two variable Taylor expansion. I will give you some example of bending of the beam like this. This is a mutual axis, and then you can calculate the bending of the beam. Okay, for reversion of the series, y can represent by x, x can represent by y, and the relationship is like this. This is another example. And Taylor series, two variable, expansion of two variable, Taylor series two variable. And these are the example. You can take a look at it. And these are the Taylor and the Maclaurin series expansion example on the cosine x. And you can see you can derive it this way. And these are error is how much. So this another example of the e to the sine x and cos hyperbolic cosine more by hyperbolic sine. And I will give you some other example like this. Taylor expansion also useful for differential equation, and these are the example. And you can see you can solve y equal to a Taylor expansion. And these are some example. These are some example. Now Taylor series can be used for evaluation of the limit. Even 0 by 0, it actually can evaluate by taking differentiation. Is called L'Hospital rule, and these are the example. For example, sin x divided by x limit when x equal to 0 is equal to 1. These are the example. So you can actually take the area. This is greater than this and greater than this, and eventually you will see the limit of sin theta divided by theta equal to 1. And there are other ways we can use the hospital rule to do this. So these are how you can evaluate. So this limit actually is equal to differentiation of this. So this is called hospital rule. You can keep differentiated. These are examples. And later on I will show you both 0 or both function 0 or both function are infinity. Also is the same way you can evaluate the limit. So these are L'Hospital rule. So basically you can do this, and these are the indeterminate form, 0 by divided by 0. You also can be used infinity divided by infinity. And these are some of the examples using the hospital rule. And you can see even infinity divided by infinity, you also can use this method to find the limit. And these are examples. Evaluate the limit. Another example using the hospital rule. And this just saying that even infinity is also applied. And some other example. And some other example. This is some of the differentiation of function. So for your information, differentiate up second, differential integral. So these are some other example. And these are some other example of getting the limit. And you can see from the example